Hi, so unfortunately, I realized about as soon as I stopped recording, about a 20-minute video, that my mic was turned off the entire video. Um, so, if I am seeing a little bit rushed, that is probably why, because it's like midnight and I'm just trying to like get this done. Um, but so if things are not clear, please let me know, and I will clarify them. But in this video, we're going to be talking about graphing a rational function. Now, let's just hop into it. There are a few questions that you'll be asked when presented with a function to graph. Typically, so you'll see the first, it doesn't matter what order they're in, but typically you'll see something like, what is the domain of f? Now, the domain, we cannot have anything. Domain is going to include everything except for restrictions and asymptotes. But we need to find what those asymptotes are. Or holes. So in this equation, we have a denominator that has an x in it, which means that we are going to have to find when that equals 0, because we cannot have anything in our denominator equal 0. So we're going to set 5 minus x and x plus 8 equal to 0. And then we're going to solve for x. So x equals positive 5 and x equals negative 8, and they actually cannot equal that. So our domain is going to look like negative infinity to negative 8 and negative 8 to 5 and and 5 to negative positive infinity. So you have that. And coincidentally, conveniently, these that we found here, these x equals 5 and x equals negative 8, these are going to be our vertical asymptotes. Now, another question that you'll typically be asked when you're given a rational graph to graph, I guess, is find holes of the graph. Now, a hole, vertical asymptotes and holes are different in the fact that vertical asymptotes typically follow but never cross that line. But holes cross the line, they're just undefined at that spot. And the way that you know it's a hole is typically if it's something like x minus 4, x plus 3, divided by x minus 4, and like 7x plus 5, where these will cross out. But you still need this data. There's still a hole in that graph where it crosses. But that's a hole instead of a vertical asymptote. And that's one thing that you want to keep track of. So in this case, our graph has no holes. Next, it wants us to find the x and the y intercepts, if there are any. Now to do that, to find the y-intercept, we need to set all of our x's equal to 0. So we have 0 minus 4, which is negative 4, divided by 5 minus 0, which is 5, times 8, which is 8. And so we get negative 4 over 40, which is the same as negative 1 over 10. So our y-intercept is going to be 0, comma, negative 1 over 10. Now our x-intercepts, we want to know when our equation is going to be equal to 0. So we have x minus 4 over 5 minus x plus 8. Now the fancy dancy way, that is trusty dusty, is to set this whole thing equal to 0. But I know when I have a fraction, if it's 0 over anything, as long as it's not 0, then the function, then that value is equal to 0. And so long as there's no contradictions here, like it can't be, if it was a whole, I don't know, it'd be tricky. But in this case, I mean, you would just like, for that you would get rid of that thing. But in this case, we just need to set this top equal to 0. Sorry, that was weird wording. And then, and in that case, our 0 is going to be equal to positive 4. Hopefully that made sense. Equals, 4, 0. So we have our x-intercepts and y-intercepts. Typically now it will ask for vertical asymptotes. Lucky for us, we already found those when we found our domain. And then the horizontal asymptote. Now, the horizontal asymptote is the trickiest because there's a few things that you need to remember for that. Namely, so let's say the degree of the numerator is going to be m, and the degree of our denominator is going to be n. Now, if the degree of m is less than n, then your horizontal asymptote is y equals 0. If m is equal to n, then your horizontal asymptote is going to be the ratio of the leading coefficients of that thing. So if you had something like 2x squared divided by x squared, like plus 4 or like plus 3, you would only be looking at these coefficients, which is 2 and 1, 2, and then the ratio of that, which would be 2 divided by 1, which is the same as 2. In this case, we only have our degree is 1, and then we have an x squared because this is not fully foiled out. And so we have a 1 over 2. If you had something like m is greater than n, then you get an oblique asymptote, which is like the sideways ones. Diagonal. And then the way to find your oblique asymptote is basically to just like divide your function that you have, and then you would be looking at the quotient of your function. So it'd be like whatever this is, divide by whatever the top is, and then whatever the top is, you don't really care about the remainder as much. You just worry about what the top is, and that is your oblique asymptote. Now, in our case, we have 1. Our degree of our numerator is going to be 1. Our degree of our denominator is going to be 2. And so m is less than n, which means that our horizontal asymptote is going to be equal to 0. Y equals 0, to be more specific. And then typically another question that you'll be asked is to test for symmetry. It's also find the oblique asymptote, but we figured that one out. You just divide and take the quotient. Now we want to test for symmetry. If you remember how to do that, it's basically just testing if the function is even or odd. If it is an even function, which is when f of negative x equals f of x, that would be even. And if it's f of negative x equals negative f of x, then that would be odd. That seems like a minor difference. It's not. If you had something like x cubed plus x squared, f of x to the negative x would just be negative x cubed plus x squared, but negative f of x would be negative x cubed minus x squared, because the negative would be distributing to each of the terms. Anyway, that's a minor tangent. In our case, our function is neither. We can test that by so we have x minus 4 over 5 minus x plus 8. We're going to make the x negative, so we'll have negative x minus 4. I already can tell that that's not going to be the same as my original. And then to test if it's odd, I guess I'm still going to need to do that. So x minus 4 divided by 5 plus x and negative x plus 8. And then to test if it's odd, we'll multiply the whole thing by negative, which is the same as multiplying by negative 1. So the top gets distributed. So we get negative x minus 4 divided by 5 minus x and x plus 8. The reason why it doesn't distribute is because we're multiplying by negative 1 over 1. So it's neither. Then you'll be asked to locate the graph with respect to horizontal or slant asymptote, if any. Now, if your horizontal asymptote is just 0, before I start with that, one really nifty tool that that I've been taught, I call it my calculus professor called it a wiggle graph. I don't remember what the actual term is, or if there is an actual term, but it's basically just like the sign test, where we want to find when the values are positive and when the values are negative. And so I'm going to add that there. Let me fix this because there's going to be 3 points. Typically for the sine graph, what I like to test points for is near the vertical asymptotes, so -8 and 5, and then near any x-intercepts that you have, which in this case is going to be +4. And then I want to test values near that range, so -9, 0, 4.5, and 6. And then I'm going to when the horizontal asymptote is equal to 0, I'm going to just plug these values into my function to see if they are positive or negative in those quadrants. I find that this one's positive, this one's negative, this one's positive, and this one's negative. And you are pretty reliably sure that these are not going to change. However, if you have a horizontal asymptote that is different than your than 0, what you'll need to do is you'll need to do f of x minus your horizontal asymptote. So if it's a -2, you'll do +2, or if it's just a +2, you'll do -2. And it looks wonky, but the way that you would do it is basically you'd have your x minus 4, that's still too big, x minus 4, and then over 5 minus x, and x plus 8, and then -2. And you want you want to have the same denominator when you are multiplying or subtracting. No, sorry, not multiplying. Adding or subtracting fractions. So 2 times 5 minus, sorry, that should be x. Sorry, sleepy brain. 5 minus x times x plus 8 divided by 5 minus x times x plus 8. Then you can distribute this. You get like x minus 4 minus like 2x squared, blah, 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 blah. It's not applicable in this case. But once you have that function, you would just be plugging in these values to test if it's positive or negative into your new function. And the reason why we do that is because if the horizontal asymptote is 0, if it's a negative number, then we know it's going to be below 0 on our y. If it's a positive number, it's going to be above 0. It's going to be a positive number. But if you have a horizontal asymptote that's at like +2, what if it's like right here? If you plug something, if your graph looks something like, I don't know what an example would be, but something like this, and you plugged in a number from here, like somewhere here, it would technically be positive if you plugged it into your original function, but it would be negative when you are comparing it to your horizontal asymptote, and that can throw things off. So the -2 just like shifts it down 2 to make it so it is in its correct spot. So with that, now we have a holistic view of what our graph is going to look like. Now we'll get into graphing it. So the steps to graphing is I typically start with my vertical asymptotes first. So we have -8 and we have +5. And then I go to my horizontal asymptote, which in this case is just 0. Sometimes you'll have a slant asymptote. Then I graph my intercepts. So I have an x-intercept at +4 and a y-intercept at -1/10. So that takes care of all of this information. Now we want to make some educated guesses on what our graph is going to look like. You don't have to do things perfectly. It's totally fine not to. But we know, so this quadrant's going to be a positive. It's going to be above our horizontal asymptote because we had a positive value for that. We know that this quadrant up to about here is going to be negative below the x-intercept. This quadrant here is going to be positive, and this quadrant here is going to be negative. And that is actually really valuable information. So if it's below the x-axis, so typically they follow their asymptotes. They can't cross their asymptote. So if it's below, it'll look something like this. Because it can't really behave any differently, right? And then if it's above, it'll be like this right here, where it's following its asymptotes. This one's a bit more tricky because you have asymptotes on both sides, but basically we start negative here, and then we cross here, and then we go up here, and we go positive for the rest of the graph, well, till we can't hit the asymptote, but that's whatever. And this would be what your graph looks like. Horizontal asymptotes are a little bit different when you're doing things. Instead of having a horizontal asymptote, you'll have one that, give me just a second. You'll have one that typically will look like something like this. And you'll still have like crazy, wacky vertical asymptotes. And I'm losing where I was at. And your graph will look something more. Let me find a way to explain. I'm going to make it something easier to look at. So your graph will look something like this typically. Hold on, let me think of a way to graph. Yeah, maybe it would look like this, hold on, I'm losing my mind. Yeah, it will look something sort of like that. It's a little bit harder to test for points on that. One moment, I'll pull that up. Yeah, I'm pretty sure that you, sorry. I'm pretty sure that you do the same thing where you do f of x minus whatever your asymptote, your oblique asymptote is, like x minus 1 or whatever, something like that. But yeah, and then you do the sign test for that. If you have any questions, I know I was being kind of quick, even though it was a 16-minute video. It used to be 20 minutes. If you have any questions, please let me know, and I will clarify for you. Yeah, have a good one.